So it looks like we're live. Cool. Let me just set up some stuff. Okay, so everything's set up. I think so. Okay. Let's see. Free mouth, healthy. So we're good to go. So we're gonna have another game night. I'm sorry I started late. Got distracted by a meeting that ran over. So we are going to do some digital design with these things. Um, yeah, let's skip the LCD one. That one was overall. Little help, tag, you're it. Okay. I don't really want to read this completely. Okay, let's just open this in. Let's just go delete that, delete that. Okay, let's open up a design, right? Kit is a simple. Do we need to full screen this? Is this? How do I zoom out? This is not good. We have things and I can't zoom. Oh. Okay, there we go. We can do that. Doesn't work the best. Okay, so here we go. Laser tag equipment. It is a simple input connected to an array of laser sensors on a vest. So we have a simple input, I guess 0 or 1. Yeah, 0 or 100, right? 0 or 100. Respawn is a simple input connected to a quick connect jack on a vest. Boom. Alive is a simple output connected to an array of LEDs vest on a vest. Okay. Trigger and reload are simple inputs connected to the switches in a replica gun. Fire is a simple output connected to a laser effective module in a replica gun. When the player is hit, their vest should be set to not alive. Okay, sure. Um, show profile, hide profile, show profile. When a player respawn, their vest should be set to alive. Okay, so when a player reloads their gun, whether alive or not, their ammo count should be set to the ammo reload value. Um, what is our ammo reload value? Um, I have to use that. When a player is alive and pulls the trigger, do we have a trigger over here? We have trigger. The ammo and it has ammo in the game should be fired. The ammo count should be decremented by 1. To allow for the ammo reload value is set by the operator using a dial that is connected to an X bus input. Um, so we have this thing. Is that a listed part? Okay. Uh, so is this just is this we read this value? Okay. So show tabs. Um, right? So if we do this, right, and I say, oh, sheesh. How am I supposed to remember this language reference card, right? Right. Let's just move x1 into ACC, right? Um pin sorry, x0 into pin 111. And let's step 5 5. Cool. And no waiting. Power. Look at all that power it's using. Okay, reset. Okay. So we assume, can we change the style? Like, I don't see a easy way to change that. I know the buttons we could press. Well, okay, so we'll just assume that that value needs to be red. It's cool. It's like it's just it's a ROM. It's a simple ROM that we have to read. Okay, dokie. Um, uh, let us say, ooh, we have a bunch of memory arrays. That could be interesting. But in all honesty, these are all simple outputs. Boop. Oh. Let's make sure it's the DX300. Can I go look at the DX300? Uh, so we could just write values to it. Okay. Um, ooh. Trigger, reload. So status. Can we write to this and then read to it? You know, like so let's get a big boy, right? Um I'm not sure which one that is, right? I don't what happens if you flip it? Let's assume it's P0 in this motor 0. P0. So yeah, let us we're going to move 100 into x0. Yeah. Okay, reset. Now, what happens if I can we use that this is like as a register, right? Can we use that as a register? So can I move x0 into ACC? Step, boom, boom. Okay, I can't use it to save a value. That's kind of annoying. So we have to well, what's the things we need to know, right? We need to know if we're live and our data. So we should be pretty good. Um, oh, and ammo. Yep. Okay, so going back to our information, it looks like we want to assume that we start dead. Okay, we can do that. Assume we start dead and with no ammo. Um, it doesn't tell me what she started to, right? Doesn't tell me the initial values. This is terrible. Reload. Okay, we're not firing until we reload. Okay, so assume both things start at 0. And um, where is our conditional statements? Um, ooh, how do we do a mask read? Um, can we assume the reload will happen independently? Yeah. tell. Um, well, we could do greater than, right? Like it's a binary. We could do greater than. Uh, fire is the last one. So yeah, this is the least value. So we would do grade is greater than it would be in this situation greater than 9 uh x 0. Yeah. So oh x2. If x2 is greater than 9 plus we do what? We are going to set we're going to move x3 into that. We reload. Yeah. And then wait. I want to. Oh no, is it? Was it? It is. What's the statement? Don't move, jump, sleep. Oh, let's sleep one. Sleep. Okay, let's see. Um, advance, advance. Um, greater than 9. How is that greater than 9? Okay, okay. Advance. Reset. Okay. We have a text. Oh, I didn't see the chat. So, okay, the chat. So, what is this game about? If you're watching, sorry. This game is kind of a digital design game where you have blocks that you can do AND gates, OR gates, or some like embedded processors where you're just trying to fill out a scenario. It's a fun little game. Okay, so step through this. Okay, reset. What? What did we read? Okay. Apparently, I need to know what x2 is in this situation. Let me see. Okay, what are we loading? Oh, I think I did it. I know what we need. Reset. We need to say x2 is greater than 9. That. Reset. X2. Move x2 into ACC. Okay, apparently, I don't know. So that's 100. Do we reorganize it? No, no. That would be hard. So this is 100. This is 10. Um, so let's reset. Let's assume these signals are independent of each other, right? Advance, 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 advance. Whoa, 10. Reload. Okay, so that seems fine. Um, so we have one statement there. And let's do if respawn. So assume these things are completely asynchronous to each other, right? I just do tech equals if x0 is equal to what's respawned in this situation, 10. We are going to say ACC. We're going to move a 1 into ACC. Oh, not a 1. Yeah, a 100 ACC. Or can we just move this into, let's try this. Let's move that into x0. Step. Advance. Oh, you're right. My bad. We just have, a sleep one right here. Okay, so that's why I thought. So we want to move this into ATC, and then we also always want to move ATC into X0. Advance, 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 advance. Okay, now let's do the die feature. Die feature is if X0 is 1. Move 0 into ATC. Okay. Advance, advance. So right here, we're gonna die. And it's that simple. So now we're just going to do a double conditional, right? Okay, if we shoot, which is gonna be 100 apparently. X2 is 100 plus, and if is greater than, if ACC is greater than 0, we're going to subtract. How does that work? Sub. So I just do what, sub 1, and we move a 1 into x2. Oh, I see an issue. Okay, so this needs to be dat. Be dat. Be dat. Be. Okay, advance. Oh, who moved 100 into? Oh no, that's fine. Uh, uh, oh, and the last conditional is that equals 100. Okay. Whoa. Super low in the conduction cost, super low. Well, guys, we did a great solution here. And you dev, you random, we beat you by a lot. Sweet. Return to email. I made some assumptions there that were very valid. Okay. I got time for at least one more. Yes. No. Color changing vape pen? This is kind of weird. Okay, yeah, let's go. What do we got? What we got here? Radio RX is a non-blocking connected to a radio receiver. Red, green, blue are the outputs connected to ultra bright RGB tricolor. When a data packet is received over the radio, pulse the LED as specified. Red is the green is the duration. If the data packet is received, all pulses and interrupt that pulse. Okay, so here we receive a packet. And we see our vape pen. We have an RGB LED. I do not know to an ultra bright tricolor LED. Okay, LED. We have an LED instructions here. All right. So useful. Previous. Nope. Okay, so let's play around right here. Ooh, we need some delicate analog values for this. We may do two of these, I guess. Yeah, so here, let us put 50 into P1. Or move. Move 50 into P1. Step. Step. So that's red. That's good to know. Reset. Red. R. G. P. Step. Green. Uh, Reset. And step. Blue. Okay. Curious what the outputs on the other side are. Reset. Um, are these just the same outputs on each side? Oh, yeah, but I guess we can't even really get to those. Okay, so we need complex outputs. We can't put it. Yep, it has. We need three P's. We don't have three P's. I mean, do we really need these? I mean, so what we want to do? We want to do. We move this guy. Let's do this. Um, and your P1 should go to the red. And do. Oop. Okay. So basically, what's the information and the duration? Uh, pulse duration. So we receive a 0. Um, so will we need to? Okay, so we're gonna have to scrap that one. Do this just so we have need space. Let's see how we can do that. Can I bridge across that? Is that allowed? Okay, so what are we gonna do this? Well, let's move this back. Right on top of each other. Boop. That's perfect. Boop. Why couldn't they are they're the same duration? So yeah, let's try that. I'm still want to try the cheaper. Boop. Oh no, we have to store the values and the duration. Uh, we're gonna do that. We're gonna need three values. All right, we're gonna need four different values to store. Right. Okay. So we're going to sleep on x0. Right. How does that SLX work? Oh, I think so we can just move x0 into a star into that. Step. Non-blocking. Oh, it's we're receiving that. If so, 0 not equals. I guess we could just do pair. We're gonna say equals, right? If x0 was negative 999. And now we have things we're gonna do. So basically we're gonna move. Oh, we gotta store it first. So we gotta. Oh no! What do we do now? Because we have another value we have to store. So what do you think? I think we have to do. We have to How do we do this? Ooh, I don't know how we would go about doing that. So we have issues that we need to read the 99, but it could be valid data instead. I wish there was like a little valid mark. We just have red intensity. Oh, do I need to put another one down? That would be a pain. What do you think? I don't know other way around it. I mean, to do this, we're gonna have to do another timer. So we're gonna have to do it this close. Like, I just don't see a way around it. Okay, so this is basically, is it a valid message machine? This is terrible. Oh, we got Zhang Yon has subscribed. That's cool. Got 2 likes. See how this goes. So this seems like an awful plan. There's got to be a better way to do this. Maybe with some of these parts not recommended. How about we do this and we go look up a valid solution? So, wait, we're gonna move x0 into ACC, and if f equal ACC equals negative 999, we do nothing, but it does. We're going to move ACC to x1. We're going to move x0 to x1. We're going to move x0 to x1. And we're going to move x0, move x0. So this is like, do we have a valid message? I can't believe it's this nasty. Here, we're going to move. Oh. Then how did the other one stay strong? Let's see what happens there. We could have an issue like, how do we keep it up valid? Um, Whatever. So we get a value. The first value is the red intensity. We're going to move that into dat. So we're going to move x0 into dat. We're going to move x0 into x1. Move, oh, sorry, x2. Move x0 into x2. And then move ACC. And then we're going to say, oh, if greater than, if ACC is greater than 0, we're going to say sub 1, and then we're going to send a message. We need to move our value. We're going to move a 1 to x2, and then we're going to move dat into p1. That's all I can think of. And so in this situation, we're going to move x0 into ACC, and we're going to move x0 into dat. And then we're going to test. Test equals, if x0, this is kind of a throwaway value, if x0 is 1, we're going to move, so this is going to be G, so it's going to be, move ACC into P1, move dat into P0. Right, so let's see what happens. Reset. So clearly we need a sleep 1. Sleep 1. Sleep 1. A step. Reset. So we need a sleep x on x0 and a sleep x on x0. I'm glad it holds those values. Oh. Reset, advance. Step. Moving 100 there. Moving 50 there. Yep. Moving a 0 there. Okay, so what we need to do is we need to have a negative. We need to move a 0 into x2 and move a 0 into p1. Same thing for here. So if the negative, move 0 into p1, negative, move a 0 into p2. What are you angry about? Oh, p0. Yeah. Advance. Do. Oh. Reset. Advance. Step. Step. Oh. Let's sleep time. How can we is there a non-blocking read? Non-blocking. They're blocking buses. So there's nothing that initiates this. Oh, I know what we do. We're gonna have to do another thing here. We're gonna do a plus and negative. Move 1 or 0. We're always going to be sending something 1 so we can get rid of the sleep. Doesn't really matter. Move 1 x1. Okay. So what we want to do is we want to say if x0 is now equal to 1, that means we need to update things. But we also have to move a 1 x2 to tell it to update. So here we want to say same thing as before, 1 plus. Okay, step, advance. Do not send. Oh, this needs an additional 0. Okay. Simulating. Nasty. Okay. We did terrible in production costs, terrible in power usage, terrible in lines of code. Okay. Color changing vape pen. So let us go to the internet. Color. And I am curious to what people. This is a good. So they were able to do these two. Sleep on X, X1 to P1. Oh, I tried that. Didn't work. Oh, X clock, that one. Okay. Read the first value from X1. Test the value is negative 900. If not, set the red LED to that. Read and set green and blue. Oh, we stored the values. We don't need to store the values. Okay, that's where a misconception coming. I was storing the values, which was a little bit more work. But okay, so I was assuming we'd have to write the value every single clock cycle, and we don't. But we got a working solution. So I think well, let's see. Can we see if we can do this one real quick? X and Y are simple inputs connected to an unknown device, presumably some type of positional sensor. Are simple inputs. Power is a simple output connected. Yeah, that's what I thought. Map the XY coordinates. Geometric. Okay, so the side. I didn't. Okay. So 1, 2, 3, 4. Um, I don't think I have enough lines of code to do that now. Um, ooh, these are simple values. And okay. Um, move key 0 to x1. Move x1 or x0 to ACC. Move p0 to that. So minimal, right? If so, we divide the solution to have these values when you check these bounds. Um, so I think first we want to check this one. It's the simplest, right? If greater than if yeah, ACC is greater than 30, right? Less than no, greater than that, and then we're going to do a minus move of 30. We're going to move 30 into power. Notifications. Okay, let's oh, and do P1. And then we shall delete. Advance. What are you blocking on? Sheesh. Oh, deep. Okay, advance. So we're going to see where there is a 30. Simulate. Is it never in that? Ooh. Can we put a breakpoint there? I think we should be able to breakpoints. Okay. Advance. Another 30 location. Another 30 location. Do we never get to that category? I like, is that never a thing? Well, that's not even. So this doesn't matter. Straight up doesn't matter. So we want to do if equal to or greater than 40. Um, so if it's less than 40, so reset. What is our things? Greater than is there a less than? If AC is less than 40, um, through we're going to put a big fat 0 into P1. Advance. I'm confused. I really am. 0 is valid. Okay. I guess we could say greater or equal to 60. You can always overwrite it. Move their B into E1. Okay, now we just have these two bounds we have to handle. So basically what we're going to do is How do we do the bounds? Well, it has to be between 40 and 80, so we need to do two pluses of that. Equal to or less than 80. So we want to say t greater than tgt greater than is um, greater than 80 minus if t is greater than um, that 40. Now, if this is true, we want to look at it if oh, we want to do the same thing. TGT ACC is 80 minus if TGT AC is 40, and then plus we'll just say 50, right? Let's move 50. You want advance. Um, 30. Yeah, the fifth step. Yeah, definitely greater than 60. Um, oh, okay, can we since this is values, right? We need this to let's do less than, let's make these all positive, right? 81. No pluses. Less than 81. Simulate. Okay, it's just now these ones. Reset. So we just need another plus and minus. Um, so I think we just need to do a plus. Um, is it greater? Is it less than that ACC of 60? And if it's less than 60, 50, if it's greater, um, 80 into P1. Right, right. Simulate. Oh, step. Ooh. Ugh. How do I embed it properly? I guess we just need to have a plus train, right? It needs to be a plus train. This is all I understand. Each is greater than ACC of 9. Oh, if it's a plus train, this will be false. Uh, how do we get that conditional hidden? Well, um, how do we block that? Oh, we need a jump. Minus, we need to immediately jump. Give me my jump commands. Jump a label. And what? And and that step. If these things bounded, don't check that. No. End. Right. Advance. That's not good. 0. Um. Okay. So any of these are negative. We're going to jump and oh. Oh, snap. How dare you have that 30? We have here 70 and 80. Whoa. Can I add a breakpoint near the end? And that doesn't make sense to me. It should have dropped to 30. Okay, reset. We're just going to have to right there. Okay, advance, advance, step. Okay. We're supposed to have a 30 here. 80 and 80. Oh, it's probably just a bound issue. Um, so we go back to Poseidon. 80 and 80. Oh, those are supposed to be 80. Okay, reset. Reset. So these are supposed to be 80s. These are supposed to be 39. 80, I got them wrong. 39. Less than 60. Simulates. Oh, jerk, you have that bound. I do have this bound of less than 20. Ugh, I don't know if I can fit that in right now, guys. Where do I put the less than 20 thing? Eek. Unless we want to process the X value here, and that's what we move. Boom, boom, boom. So we're gonna move one into what, ACC, and start with if it's greater than if it's greater than ACC than 20, we're going to move a so bound, bound, bound. But we would have to process that. Okay, guys, this is becoming more annoying than I thought it was going to be. Um, so yeah, let's just go ahead and say move a 30 into the 0. Um, um, if it's greater than ACC is greater than 59, uh, Now we have to do a plus or minus. Ooh, 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 drive me insane. We only need to correct it. So yeah, let's define this one. Send a 0. Otherwise, send these two. Okay, so we want to say if it's less than 21, less than 21, no, less than 20, and plus. No, 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 we want to say we want to find this bounds. It's greater than 19, greater than 19, and less than 60. Guilty ACC 60. Then we are going to say we're going to move x0 move x no, we're going to move 0 to x1 minus we are going to move 30 into x1. Then we're gonna have a gotcha. We're gonna be like, oh, well, if it's greater than 39, so if ACC is greater than 39, and we need a plus here, but less than 80, ACC 80, we need to send a gotcha. It'd be like, gotcha. Ooh. Wait a minute. Oh no, we would just have to move move ACC to x1. Move this x1 right up to p1. We don't have to do this. We just gotta move x0 into ACC and simulate. To split up the processing a little bit. Look at that. Pretty good. There are better solutions, but yeah, I think we did pretty good. Okay, I think we're gonna call that a day. Oh, so many puzzles. I don't want to do anything. Okay, well, thanks for watching. I know we had low interest today, so hopefully this works well. It's a fun little puzzle of trying to understand how things work. Feel free to ask questions. Look at doing a Discord channel and 1,000 subscribers. Tomorrow we're putting Ubuntu on the ZCU 104. I'll figure out what we're doing Friday and post something. But thanks for watching. Have a great night.